Hello everyone, myself Krishna Kumar, chemistry expert, Dr. Krishna Kumar, chemistry expert. In this class, we will discuss the ninth class chemistry chapter atoms and molecules. Atoms and molecules. Why we will study this chapter? Because it will make our higher class chemistry easy, 10th, 11th, 12th class chemistry easy. After understanding this topic in the detail, this chapter in the detail, we will able to learn the higher chemistry easily. So I hope you will enjoy this class. What are the learning objective? After studying this chapter, we will be able to understand the historical development of the atomic theories. Historical development of the atomic theories. From ancient to Dalton. After studying this chapter, we can explain and apply. We can explain and apply the laws of chemical combination. What are the laws of chemical combinations? Law of conservation of mass and law of constant proportion. And we can able to describe the properties of the atoms, like the size and how they are represented. Representation of the atoms means using their symbols. We can differentiate between the molecules and ions and understand their formula and writing their chemical formula using the valencies rule and calculate the molecular masses. We can able to easily calculate the molecular masses. We can apply the mole concept to solve the numericals. After studying this chapter, these are our learning objective. Why we are learning this chapter. So, introduction to the matter. Introduction to the matter, we have ancient ideas. We have two type of ideas. One is according to the Indian concept and second is according to the Greek concept. Oh, according to the Indian philosopher was the Maharishi Kanda, who introduced the term Parmanu as the smallest indivisible unit of matter, and means it is the particle which can't be further divided. At the same time, Democritus and the Leucippus proposed a similar theory as proposed by the Kanda. They termed the smallest indivisible particle as the atom. Here the name Parmanu was introduced, but here the name introduced was the atom. Did you know what is the meaning of the atom? Atoms comes from the word uncuttable. Atoms comes from the word uncuttable. Uncuttable means indivisible, which can't be further divided. Means which can't be broken into smaller pieces. Which can't be broken into smaller pieces. जिसको smaller pieces में convert नहीं कर सकते. Now we will discuss the law of chemical combinations. The overview. First law is the law of conservation of mass, and it is given by the Antoine Lavoisier in 1774. Antoine Lavoisier is also known as the father of chemistry. According to this law, this law is also known as the law of indestructibility of the matter. Means matter can't be divided. Or according to this law, matter can neither be created nor be destroyed in a chemical reaction. Matter, what is matter? Matter is anything that occupy the space and have mass. Law of total mass of the reactant before the change and after the change always remains same. This is the law of conservation of mass. Conserved means which does not change during the change. Which does not change means remain constant. Suppose we will discuss this law in the next slide. Second law is the law of constant proportion. These two laws are collectively known as law of chemical combination. This law is given by Joseph Proust in 1794. And what this law says, in a chemical substance, in a pure chemical substance, pure, what are pure? Which does not have, which have only one type of particle. For example, this law is applicable only for the compound, not on the element. This is not applicable on the element, but it is applicable for the compound. What this law says, the elements are always present in a definite proportion by mass. We will explain this law also in the next slide. What is the example of this law? Water. For example, water. It is applicable. I say it is applicable to the compound only. Water always contains hydrogen and oxygen in a fixed ratio by mass, that is 1 raised to 8. 1 gram, it means that 1 gram of the hydrogen always combined with the 8 gram of the oxygen and give 9 gram of the water. These law form the foundation of the Dalton atomic theory. These law, Dalton uses these law to prepare his theory. Now, our first law, Antoine Lavoisier, given by the Antoine Lavoisier. It states that the total mass of the reactant is equal to the total mass of the product in a chemical reaction. In other words, mass can neither be created nor be destroyed during any chemical change. For example, this is the combustion of the methane. How it happened? CH4. What is the chemical formula of methane? CH4. And how it is burned? Combustion means it is a oxidation reaction, combination with the oxygen. Methane combined with the oxygen and it gives CO2 and water. CO2 is the carbon dioxide and water H2. So, mass before the change is 80 and after the change is also 80, means mass is conserved. Mass does not change during any chemical change. So, before the change, the substance before the change are known as the reactant and the substance after the change are known as the product. The change substance before the change are the reactants. These are the reactants. Substance before the change are represented by the arrow and on the left hand side of the arrow, and substance after the change are represented on the right hand side of the arrow. So this law is also known as the law of indestructibility. This law is known as the indestructibility of the matter. Means matter can't be destructed, can neither be lost. Mass can neither be created nor be destroyed. So we have one question based on this law. In a chemical reaction, 10.6 gram of the barium chloride react with 12 gram of the sodium sulfate and gives 6.2 gram of the barium sulfate and 16.4 gram NaCl. Use this information to prove the law of conservation of mass. What the law of conservation of mass says? Mass of this substance before the change and mass of this substance after the change will remain the same. So before the change, what is the mass before the change? 10.6 plus 12, it comes out 22.6. And the mass of the substance after the change, is 6.2 plus 16.4 and it comes out 22.6. Means mass of the substance before the change and after the change is same. So this follows the law of conservation of mass. Next, law of constant proportion. Law of constant proportion is also known as the law of definite proportion. Definite means fixed ratio. Composition. Proportion means ratio, fixed ratio. This law is given by the Joseph Proust in 1794. What is that statement? A pure chemical substance means a compound. A compound in a compound in a compound in a compound, the elements always present in a definite proportion by mass. Example: water. Example: water. What is the mass ratio of the hydrogen to oxygen? It is 1 raised to 8. It is 1 raised to 8. And in ammonia, it comes out 14 raised to 3. And we have one experiment or verification for this mass of, sorry, we have a compound copper oxide. We have a compound that is copper oxide. In multiple experiments, the copper and oxygen always combine in a fixed ratio of mass, that is 4 raised to 1. So we will see this with the help of this question, this figure. 4 gram combined with the 1 gram and it will give 5 gram. This is the copper and oxygen. Copper and oxygen combined in a 4 raised to 1, means 4 gram copper combined with the 1 gram oxygen and give 5 gram of the copper oxide. We have a question to illustrate this. To explain this, refer to the question. 2.6 gram of the copper is dissolved in nitric acid. Suppose we have nitric acid. This is nitric acid, HNO3, and we dissolve in this nitric acid 2.616 gram copper in it, and it gives 2.7 gram copper oxide. So what is the mass ratio of the copper to oxygen? How we will calculate it? So mass of oxygen, we have to calculate the mass ratio, copper to oxygen mass ratio. So what is the mass of the copper? Mass of the copper is 2.16, and the mass of oxygen, how we will calculate the mass of oxygen? Mass of copper oxide, mass of CO minus mass of copper, this gives mass of oxygen is equal to mass of oxygen. So mass of copper oxide is 2.7 minus 2.16. 2. We can write it as 2.70 minus 2.16. So what is the mass of oxygen? Mass of oxygen comes out to be 70146.5 gram. So we can divide this by 0.5. Or we can write here as mass of copper is 2.16 divided by 0.5, and it comes out 4 raised to 1. This is the first experiment. Now we will discuss for the second experiment. The mass of copper oxide is 3.6 3.625 gram of the copper oxide is obtained when 2.9 gram of the copper is strongly heated in air. 2.9 gram of the copper is heated in air, means there is a chemical change, heating of the copper oxide. So we can solve this question. Second question here. 2.9 gram copper is heated and it will give, it will give 3.625 gram of the copper oxide. So what is the mass of the oxygen? Mass of oxygen here is mass of the copper oxide minus mass of the copper is equal to mass of the oxygen. Now so it comes out 3.625 minus 2.9. Minus 2.9, it comes out 7 mass of oxygen. This is the mass of oxygen and it is equal to and it comes out 0.725. It comes out 0.725. So what is the mass ratio? Copper to oxygen mass ratio 0.725 mass of the this is the mass of oxygen and mass of the copper is 2.9 and it comes out 1:4. So in both the experiment, the mass ratio of the copper to oxygen is 4:1. It means that mass ratio remains the constant. Means this is known as the law of constant proportion. Means ratio of mass of copper to oxygen remain the same. Constant proportion means same ratio. In every experiment it comes out same. This ratio comes out same. Now we can take third example also. In the third example it will also comes out 4:1. So we can solve this also. A 1.15 gram of the copper oxide is reduced to 0.92 gram copper. 0.15 for the third experiment number 3. For the third experiment 1.15 gram copper oxide is reduced to 0.92 gram copper. Now what is the the reduction process. Change, chemical change, reduction. Copper means removal of oxygen. Reduction is defined as removal of oxygen. Now 1.15 gram copper oxide minus 0.92 gram copper. This gives the mass of oxygen. This gives the mass of oxygen. Mass of oxygen. Mass of oxygen. What is the mass of oxygen? सब्ट्रैक्ट करते हैं 0.92 3 2 0. Mass of oxygen comes out 0.23. Now we will calculate the mass ratio of copper to oxygen to prove the law of constant proportion. What is the mass of copper oxide? 0.92. What is the mass of oxygen? 0.23. What is the simple whole number ratio? 1:4. It comes out 1:4. If we divide this, it comes out 1:4. So in every experiment, this ratio is found to be copper to oxygen, the mass ratio is found to be 4:1. Means you can prepare any compound from any experimental method or from the nature. The elements are always combined or always found in a fixed ratio by mass. And this fixed ratio for the water was 1:8. And we can take one more example. Suppose we have a compound that is carbon monoxide and second compound is carbon dioxide. The mass ratio, if you take the mass ratio, the mass of one atom of the carbon is 12, mass of the one atom of the oxygen is 16. If you take the mass ratio for carbon monoxide, it comes out, we can simplify it as so simply it comes out 3:4. But in case of CO2, the mass of oxygen is doubled. There are two atoms, so it comes out 3:8. It comes out 3:8. How? Mass of one atom of carbon is 12 and mass of one atom of the two atom of the oxygen is 32. It comes out 32. So we can simplify it as now it comes out 3:8. From whatever the source of CO2, it may be chemical change or a physical or any natural source or any type of chemical reaction. The carbon and oxygen always combine in a fixed ratio of 3:8 by mass. It means 3 gram of the carbon always combine with the 8 gram of the oxygen and it will give 11 gram of the CO. If 3 gram of the carbon combined with the 4 gram, if 3 gram combined with the 4 gram, if 3 gram of the carbon combined with 4 gram of the carbon, 4 gram carbon, so it's 4 gram oxygen, it gives 7 gram carbon monoxide. 3 gram carbon, 4 gram oxygen, they give 7 gram carbon monoxide. This is known as the law of conservation of mass. This is the law of conservation of mass and this is law of constant proportion. This is law of conservation of mass. 3 gram oxygen combined with So 3 gram carbon combined with 8 gram oxygen, and it will give and it will give 11 gram CO2. This is the law of conservation of mass of the reactant before the change and mass of the reactant after the change always remains same. If 1 gram of the carbon, if 1 gram of the carbon, 3 gram combined with 3 gram combined with 8 gram, then 1 gram will combine with how many gram of the oxygen? 8 by 3 gram of the oxygen. If we ask the question that 1 gram of the carbon will combine with how many gram of the oxygen to form CO2, then 1 gram will combine with 8 by 3 gram of the oxygen to form CO2. And similarly, if 1 gram of the carbon combined with the 4 gram of the oxygen to form carbon monoxide, then 1 gram will combine with how many gram into 4 by 3? It comes out 4 by 3. It comes out 4 by 3. I hope it is clear to you. Next is the Dalton atomic theory. This theory is come from the experimental results or based on the law of chemical combinations, like the law of conservation of mass and law of constant proportions. So this is in this slide. This is given the biography of the Dalton. Main postulate of the Dalton atomic theory. First postulate of the Dalton atomic theory: the matter consists of extremely means very small particles called the atoms, and atoms are indestructible means can't be destroyed. That can't be destroyed. Cannot be created or destroyed in a chemical reaction. Means lost in a chemical reaction. Destroyed means lost. Each element, for example, hydrogen, oxygen, could be metal, non-metal. It may be either metal or non-metal. Each element has a characteristic atomic mass. Means atoms of a particular element, have its common characteristics mass. Means it is different from the other. Means hydrogen, an atom of the hydrogen will have different atomic mass than that of the oxygen, nitrogen, carbon, and other. It may be metal or non-metal. So each element has its characteristic atomic mass. Means it is different from the other. Atom of the same element are identical. In what properties? Mass, size, shape, and these physical properties or chemical properties. Means one atom of the hydrogen will be similar to another atom of the hydrogen. H1, H2, H3. These atoms will be similar in size, mass. They will have the same size. They have same atomic radius. They have same shape. They have same masses. Means physical and chemical property of the atom of the same element will be same. But the atom of the different element have different properties, like the mass, size, and physical and chemical properties. For example, the mass and size of the hydrogen and oxygen, nitrogen, carbon are different. Atoms combine to form molecules. When forming the compounds, means what is molecule? Group of atoms is known as molecule. Molecule may be of the same atom or of the different atom. For example, hydrogen atom combined to form a molecule that is known as H2 molecule. Oxygen combined to form the molecule that is O2 molecule.